Okay, this is my Code Golf video explanation, the cat ate your input again. Create a cat program, takes an input and prints in a classic program, except for each character, there's a random chance that it won't get printed. So it has to be between 10 and 30% chance to be removed for every character. This is the language I chose was Fish. Looks like this, it's pronounced like Fish. It is a two-dimensional stack-based programming language. As you can see, these little V's, less than, greater than, and exponent symbols are directional inputs, and it guides a little pointer around the track. 7 by 5. 7 times 5 is 35. That's how the bytes were calculated. 35 bytes, which I'm pretty proud of, but I'm sure there's still somewhere improvements to be made. So let's write to the input stream. Hello world. Says the execution speed is slow, so I can pause it. Clearly did not pause it fast enough. So what it's already done, it's taken a number or taken a letter from the input queue and changed it to its ASCII value, and plop that on the stack. Then it has duplicated that number on the stack. It will now push one onto the stack and add those two numbers together. And then this is the conditional. So if the latest number on the stack was 0, which it wasn't, it was 73, it would have skipped this command. But obviously, because it was 73 and not 0, it did not skip that command. The command in question is the trampoline command, which would have skipped. Oh no, because this did not skip this command, this is the trampoline command, which skips this command in turn, which is just down. And because this, I like to say this language operates on Pac-Man rules, warps around to the other side. So it should keep doing this until the input queue is out. And then, as you can see, it returns -1 right here because there's nothing left in the input queue. That's why we add 1 to every single one, because now it is 0, skips the trampoline, it goes down, removes this. Then there are 2 trampolines in a row. This string was just so I could compress it further. This X right here, if it goes up, I'll explain this later, but if it goes up, it will, essentially not have to activate this plus command. So it skips the other trampoline, then puts 0 at the, just plop 0 onto the stack, and then reverses the whole thing so that 0 is like a little indicator like, hey, the string's done printing, and now the string is in proper order to print. And this is probably where you could shave the most off of this. I'm sure this is not a very efficient solution, but I don't know. This is the best I could do. I mean, I'm sure if I really, really put some brain power into it, I could probably shave this off a little, but someone much smarter than me can do it a lot faster. Anyway, so goes down, right? Skips this command right here because that's the test case for the left. So let me explain this. This is this is the randomness. This is what makes everything random. It's also really cool, directly in the middle of the entire program. So there's a 25% chance for it to go left, 25% chance for it to go up, 25% chance for it to go right, 25% chance for it to go down. 1 in 4 chance for each, right? That is between the 10% and 30% boundaries. So let's see what happened on this one. So as you could just see, that's why I put this there. It went left. It can go back in the direction it came from. So it goes down, which was skipped previously to get here. Goes down, right, down, left, and then as you remember, the to check if it's conditional, it pops something from the stack, so I have to duplicate it, and then it outputs that. So as you can see, we get the H. Now let's keep going. See, it jumped up, and I had to skip this plus command. So Pac-Man rules once more, comes back down, and then does all that again. Let's see if we can. Okay, this is the removal. This is the 25% chance. So as you remember, the conditional, it pops the pops the value off the stack in checking. And so this is here because I used to have a 40 byte design in which if the last if this 0 got the 25% chance to get deleted, it would just like throw up an error. It would not work because it would try to remove from a nothing stack, and obviously you can't do that. But there is not a nothing stack here. It is greater than 0. Well, it's not equal to 0. And so you gotta so this command is not skipped. This semicolon command ends the program. So it's essentially saying like, hey, if you're 0, just quit because you've already printed everything. And then that is all the interesting cases. If it just goes like if it just goes down, obviously it'll just do that. So let's resume. I believe I've talked about everything in this language. Uh, oh yeah, and so as you can see, it deleted the L, the space, and the O. And that is it's 35 bytes. Really proud of it, but I'm sure there's some shaving that could be done. Thank you for watching my explanation.